Hello, everybody. Good morning, good evening, depending the time you are watching this video. Welcome to this channel. And if you are new to this channel, kindly consider to subscribe. We are growing as a community, so be part of this community and expect more content like this. Yeah. So as I promised, this time round, at least you will be getting 3 videos in a month. So be just subscribe and hit the notification bell for a new update. You'll be able to get it immediately. So in today's video, actually, it's a continuation of a video I did last time, which is part one. On still we are talking about the why missing data really means, what missing data really means in applied research. So this is a continuation of part one. So in part one, we discussed missing completely at random, a scenario, which is actually a rare but an important case, and we discussed on how it's being done, how we can be able to test it statistically, and ensure that we are making the right assumptions. However, in today's video, in this video, we move to missing at random, MAR, the assumption behind the most applied research and multiple imputation. So I think this video now is going to answer majority of the questions many of you are asking themselves. Maybe when do I use multiple imputation? How do I know that my data is missing completely at random or missing at random? So this video will help you make that decisions and come up with the right or the correct assumptions. So just watch it until the end and you'll be able to get everything. So this multiple at random scenario, as I've said, the assumption actually is behind most applied research and the multiple mutation. So we need to understand first of all, by definition, what is this missing at random? What missing at random actually means? So we say that the missingness depends on observed data, not on the missing values themselves. So what do I mean by this? So if we have a data, and like in this case, we there's a data that I attached last time. If you watched part one, so it's on my website. You can be able. It's a free. You just create an account, a free account, and you can be able to access everything. There's a documentation, and there is a Stata-do file and the data itself. You can use it to maybe for practice and so on. So for instance, this is the data we are using. So we say that the missing we say that by definition missingness depends on observed data. So for instance, if we are like in this case we are going to talk about income, like this income you can see it has missing some missing values. So the missingness depends on observed data. So observed data we have here is either age and education level. So it means that this missingness depends on the observed data, like the complete data. So that's what we mean, but we are going to justify that scenario. Good. So the next thing, so by definition, we say that the missing at random refers to a situation where the probability that a value is missing systematically depends on observed data, but not on the unobserved or missing value itself. So it does not depend on those, like the income variable that I've just showed you. The missingness does not depend on those dots you see there in that data. It depends on the observed data, the complete data like age and education. What education level in that case. In other words, once we account for certain variables that are fully observed, the missingness can be explained without needing to know the missing values. Exactly. So this supports now that scenario. The it's supposed to a point that I've just told you that the completeness, the complete data that we have in that data, variable I mean, the education level and the and what and the age. So it supports. So we use it now to make the decision or to account the missingness in a income variable. MAR, which is missing at random, does not mean that missingness occurs randomly in the everyday sense. Instead, it means that missingness is conditionally random given the observed information in the data set. Yeah, that's a good point. So it doesn't mean that the data is just missing randomly. No. So the missingness is conditionally random given the observed information in the data set. Like in this case, we are going to see how this income and the education level is actually a condition. Is condition is a condition in this case. So we are going to see it practically, but that's the point. So under missing at random assumption, the mechanism causing missingness can be modeled using observed variables, which makes principled statistical collection possible. This is the good assumption. Actually, now this is where the multiple imputation comes in, and in your analysis or in your research or in your project, if you have missing data, you have to prove or you have to justify. If you justify that the data is missing at random, then you have an authority to use multiple imputation. So you can now do the modeling based on the observed data, like the observed data. In this case, we observed variables, sorry, we mean that those variables that have complete data, no missing data, then you are good to apply the multiple imputation. Okay, the next step is now to compare missing at random versus missing completely at random. Number one, missing completely at random, missingness unrelated to anything. So the missing data or in under missing completely at random actually is unrelated to anything, not observed nor unobserved data. Then under MAR, missing at random, missingness related to observed variables. And I've said observed variables, these are the variables you get in your data that has complete data. You understand? But you have to justify. Let me insist on that. Good. So, next thing, why multiple imputation is untestable. I said in part one, actually in these three scenarios, missing at random, missing completely at random, and missing not at random, the only scenario where that we can statistically test is missing completely at random, and I presented that in part one. You can go and watch that. You can be able to understand. So that's the only scenario we can test statistically. Otherwise, the other two, missing at random and missing not at random, we cannot test it statistically, but we can justify it using some theories and so on. So why missing at random is untestable? A good point. Cannot statistically prove. We cannot statistically actually prove missing at random. I've just said that. But missing at random is justified by number one, the theory, number two, the design, number three, observed data relationship. So those are the three things that you need to consider for you to make a decision that your data is missing at random, or maybe you are in a position to use multiple imputation. So you use the three points. So the theory, the three aspects: the theory, the design, and observed data relationship. Then multiple imputation now under missing at random. So multiple imputation, the first assumption is that multiple imputation assumes missing at random. So then the means if you justify that your data is missing at random, then that's the first the scenario where you use multiple imputation. Correct model specification is essential. So still you need to ensure that you have the model specification is correct, all the assumptions, because if you give the wrong assumptions, then your model will not make sense at all. So now in this ML, I can say this is the foundation of multiple imputation, because we say that the multiple imputation relies on the idea that the missing values can be predicted from observed variables. That's about, so if you use missing data, multiple imputation, you must you must have in your data, you must have observed variables. And observed variables, I've said in this video, is those variables that have complete data. So, like in our case, if we assume, if we are going to justify, not assume, if we are going to justify that this data is really missing at random, and we have used some theory, the theory, and based on the observed variables, and indeed you have seen that this data is missing at random, then we can do what? We can apply multiple imputation. So under the multiple missing at random assumption, this is defensible. Actually, it's defensible strategy because the observed data explain why values are missing. So that is the key thing you need to consider. Then so when do we apply when multiple imputation is applied correctly? When do we say that this multiple imputation has been applied correctly? So number one, the imputation model incorporates variables related to missingness. Then point number two, uncertainty about the missing values is properly reflected. Then that's three, statistical inference remains valid. So those are the three points, or the three key points when we can say that multiple imputation is applied correctly, and you need to consider them in your study. So all these things I'm saying, actually I have a documentation of the entire video, so it's on my website. You can be able to go and download it, and you can be able to do what to go through it and read it. Then okay, common mistakes in missing at random and multiple imputation. Number one, too few predictors. So the number two, ignoring outcome variables and treating missing imputation as a pattern. So those are some of the common mistakes that we encounter in this missing at random and multiple imputation. So when missing at random is not credible, so this is there is also limitation to this. Number one, sensitive variable. So if we have, like in this case, we have age, we have education. So if we have sensitive variables, then the MR missing at random is not credible. Number two, non-response bias. The number three, dropout due to unobserved outcomes. So for more information on this, expansion on this, you can get it in the video, or in my website. So the document is there. Now allow me to showcase something here. This data that I'm going to use, you can see, using now the summarize, missing table summarize, I can be able to see what is the pattern, or what is the summary of the data that we have in this data. So number one, if you look at this table, so many people misunderstand or misuse this kind of table. So actually, what this table tells us is that income, it has 24 missing values, job satisfaction 9, health score 21. So this table tells us how much data is missing, not why it is missing. So this the mistake, this is the common mistake that they have seen outside there, but that's how you interpret that table. It just tells you how much data is missing, not why it's missing. So that's all. So you don't complicate things in this case. So I want us to do this. So I want us to practically now, or by theoretically, prove whether this data is missing at random. So, and I'm going to use the education level and the age, because they are the observed variables in this case. They have complete data. So if I go to, I do this mdesk, you can realize the education level and the age, they have zero missing values. So they are observed variables in this data, and I'm going to use them to do what? To theoretically to justify whether this data is missing at random or not. Last time we used the same data, and using the test statistic under missing completely at random, we justified that the data is not missing completely at random based on the p-value which was less than 0.05, which permitted us to do what? To reject the null hypothesis, which tells us that the data is missing completely at random. So the first thing, I need to create a missingness indicator. So in this case, it's the income. So I'm taking the income as what as our variable to tell us whether this data is missing at random or not. So I regenerate a missingness indicator. Actually, those means is so already it's there. Let me drop it so that you can be able to see put like that. So I create that variable like that. So if I click tab, you'll be able to see 0 and 1. Actually, it's a binary variable with missingness represented by 1 and 24, non-missingness. So we have 96. I mean complete data. Then I have now to examine the association between observed variables. So, and I told you the observed variables we have here is the age and education. So education is actually in this case is a categorical from primary and to tertiary. So we cannot use summarize. We use tab. So frequency. So we use tab income, the indicator against education. Good. So if you look at this variable, you can be able to see something. Non-missingness. So for primary, we have 16, secondary 16, tertiary 16, postgraduate 23. But if you go to missingness, primary has 12, secondary has 12, tertiary is 0, postgraduate is 0. So what does it tell? What does this tells you? What we get from this is that this income is only missing on those individuals with the role with the either primary or secondary, with primary and secondary education level. So meaning those with the tertiary and the postgraduate, they have what? Okay, we anticipate actually those people maybe they have what jobs, they are earning well. You see, maybe primary and secondary actually they have not maybe secured a job. You understand? So something like that. So you can see now we have started seeing some pattern, some systematic pattern. Like in this case, those with their primary and secondary, they have missing data. They like based on the income. But those with the tertiary and postgraduate, they have none missing data. So I think you can be able to testify that. Then let us see now the age. Let us see the mean age for those with missing data against those without missing data. So if you look at those with missing data, their mean age, if you compare, actually they kind of younger compared to those with non-missing. So we can say from these two scenario, actually from the pattern, number one, this pattern indicates that the income missingness is not random. You understand? But instead, it is strongly associated with an observed variable. You understand? So like the age and the education. I think that's the key point. So the pattern indicates that the income missingness is not at random. So it's not completely at random, but it depends, or it is strongly associated with observed variables in this case, which is education level and what and the age. So as a result now, based on this explanation, we can actually testify that the missing completely at random assumption is not applicable in this data set. And you can testify, you can agree with me based on the what? Based on the part one, we found out that the b value for missing completely at random was statistically significant. It was actually 0.0012, less than 0.05. And in that case, we rejected the null hypothesis, which indicated that the data is missing completely at random. So we see that now that was correct because this data is missing at random based on this pattern that I've just explained in this. So another thing you need to understand from here is that this missingness does not actually appear to depend on the unobserved income values themselves, so like those values that are missing under the income. So it does not depend on that. Rather, it depends on educational attainment or the age. Good. So now we can say that based on this, actually we can conclude now based on this the test that we are sorry these statistics we have done here. It is evident that the income missingness actually is systematically associated with observed characteristic, which is the educational level and the lesser extent to age. While of course while I said this area, while the missing at random cannot do what cannot assumption cannot be formally tested as like missing completely at random, but sorry, but the observed patterns provide advanceable and transparent justification faction for treating now income as missing at random. So we cannot actually statistically we cannot test this missing at random, but using these observed patterns as you have seen what I've just done here, we can now provide advanceable and transparent what justification for treating income variable in this data as missing at random. So it means that if we have reached to this point, so under this assumption, multiple imputation is an appropriate method for handling missing income data, provided that the relevant observed variables are included in the imputation model. That is it. So you see, up to that point now, you have made a decision. We have made actually a clear, a transparent decision that this data indeed is missing at random, like the income variable is missing at random. Then we have an authority to use what we call the multiple imputation, whose first assumption is the MR assumption. Like it assumes the data is missing at random. Yeah. So we can now say that with the authority that income is not missing randomly. I think this is where we need to make it clear again, no, maybe not to confuse. We have not just said that the income is missing randomly. You understand? So income is not missing randomly, but its missingness is explained by the observed variables, making making what? Making making the missing at random assumption appropriate and multiple imputation defensible in this case. And actually that's exactly what I wanted you to get from what from this video. And I think I've put it clearly, and I've shown you how to theoretically how you can do what how you can test or like the systematic pattern on your data for you to conclude whether the data is missing at random. Then maybe from that step, maybe if you can if it's missing at random, then you are free to use multiple imputation. So I hope you have enjoyed this video. Please, if you have any question, you need any assistance, you need any private training, you need help with your project, such project maybe is statistical analysis, data cleaning. I'm free. I'm free. I can be able to help you. So just check on the comment section on my website. You can reach me out, and we can help each other. Yeah. So in the next video, which is actually our part 3 now, I'm going to discuss missing node at random scenario and why standard multiple imputation may vary under missing node at random scenario. So just be be ready. So just click the notification bell. So once the video is actually up, you'll be able to get that video. So thank you for watching. See you next time.